Morning, Brian.
Morning, Steve.
Hey, you're going to be taking notes along today, right?
Correct, sir. Yeah, I was
Okay.
actually just about to text you, let you know I was here. I was going to take notes, and then I'll facilitate the section, the open discussion and action items at 4. If I get something in the chat, you want me to text you about it, or if there's something that you don't seem to see that should be addressed, how do you want to handle that?
I guess if you just send me an email, if I
Okay.
miss it, just say, "Hey, Steve, check your chat" or something. During whenever anybody else is speaking, and then I can look. Or else we could do it at the lunch break or the 5-minute break there right before your session starts. Your part
Okay.
of the session.
All right.
Yeah, I'll try to keep my eyes posted for the chat while people are talking. But I also asked Jeff Ullmeyer to take notes as well, and either one of you to stop me if especially when I do these questions for the survey questions with Mentimeter, if I don't have that right.
Okay.
um, like tell me, Steve, it's not showing, or we can't see it, or we lost the connection or whatever.
Okay.
Do you know how to? I guess I could post the link for the Mentimeter in the chat, because I didn't know how to send the code to everybody or a hyperlink to everybody that's attending. I don't want to send it to 160 people that we invited if only a third of those are actually attending.
I think putting the link in the chat would be good, and then just alerting, as you're changing speakers or something, alerting people that there's a new link for something in the chat,
Okay.
for them to go look at.
Okay. Yeah, I wasn't sure where I wanted to insert these Mentimeter questions other than the customer satisfaction questions at the very end. But I
Right.
had 9 of them, and I was thinking, well, maybe I'll see how we do for a lunch break. And if we're going to be done a little ahead of time, that'd be great. If not, I guess I'll try to put a couple in between each of the speakers that are 30 minutes each.
Yeah.
Okay. Well, I don't know if you noticed, but I started a recording of this.
Yeah. I see that at the top of the screen now. I had missed that initially. So it appears to be recording.
Yes. Yeah, just the Mentimeter survey questions was the only challenging thing that's still left open, I think, for me, for where it fits in the agenda.
Yeah, I find them troublesome as well.
Okay, people are starting to attend here.
Hey, Steve.
Good morning, Steve.
Hey guys, good morning. Steve Monica Gerardo called in sick today and tomorrow. She's fighting the flu right now, so she might not join us.
Oh, okay.
We'll see.
Good morning, all.
Morning.
I hope you
How are
have
you doing,
had
yeah?
good. How are you, Brian? I hope
Good.
you had a good Thanksgiving holidays.
Very much so. Hope you did as well.
Yeah, these were very nice holidays. I mean, I don't know if they moved the World Cup to November and these 4 days it was very nice to watch a lot of games.
Morning, Steve.
Good morning. How is Mike?
Not too bad. Had a good Thanksgiving back in New Jersey and New York. And now I'm back home in St. Louis, trying to get everything prepped now for Christmas.
I was talking to Mary Robbins. She said she needs to give you a call someday.
Yeah, and I probably even just about passed her with the U-Haul truck last week when I was headed to New Jersey. So
Okay.
Yeah, I hadn't interviewed anybody this year. The lab takes them all.
Yeah, that's right. I mean, um,
How many expecting, Steve?
Okay, everyone, good morning. We have about everyone that had confirmed so far. There might be some others coming in that are just now confirming, but we might as well get started because we are in a little bit of a time crunch. So I want to pull up the agenda and share this with everyone. Is there anyone who cannot see the agenda on the screen now?
Looks good, Steve.
Okay, great. Well, welcome to the Continuous Non-Destructive Evaluation, or NDE, technologies for evaluating asphalt pavements with emphasis on moisture damage, virtual user group peer exchange. We have it scheduled for 11 a.m. today to 4:30 p.m. That's Eastern time. We're using the MS Teams functionality. I'm Steve Kozer. I'm with QES. I'm a senior engineer with QES. And the purpose of today's peer exchange is a follow-on to the Sharp 2 R06D effort. And the exchange will hear from stakeholders on recent advancements and implementations of NDE technologies for asphalt pavements. The peer exchange is also intended to promote the proposed pooled fund solicitation 1569, which is continuous bituminous pavement stripping assessment through non-destructive testing. It is now a pooled fund study, so it's now TPF 504, and that is being led by MnDOT. The peer exchange will allow MnDOT to discuss their pooled fund proposal today, which is a study, along with hearing from agencies on related research findings and issues. The objectives for today are to obtain a summary recap of the peer exchange conducted about a little over a year ago, back in September 21, with follow-on recommendations. Also to obtain an update on MnDOT's new pooled fund, as I said above, study, TPF 504, and feedback from potential participants. They have some participants already, and that's how it became a pooled fund study from a solicitation. Also obtain an update on related research conducted by MnDOT this year in 2022, and then share information by others interested in this effort, as well as sharing information and knowledge of the efforts and benefits and uses of, or in combination with other technologies. So that's the purpose and objective for today. And I'll start off by just giving you a short welcome. And those were my opening comments about the purpose and objectives for today. We also have that with us FHWA, and they are the ones supporting and asked us to tasked us to help support them with this. So I'm going to turn it over to FHWA for them to provide a brief welcome. That'll be from Stephen Cooper.
Okay, thank you, Steve, and good morning, everyone. I hope everyone had a great Thanksgiving holiday and hopefully didn't gain too much weight. I know I did. Federal Highway, we're pleased again to be hosting another virtual user group peer exchange. Again, it's focused on continuous non-destructive evaluation technologies for evaluating asphalt pavements. But this time we want to focus on the assessment for pavement stripping. As Steve said a little bit over a year ago in September of 2021, we hosted a similar exchange, and at the conclusion of that event, we were talking about strategies to continue this advancement effort, and we were very pleased at that time that Minnesota DOT graciously accepted to be the lead of a new pool fund project. And like Steve said, the pool fund project itself is now approved, and we have a number of agencies now that have committed to that pooled fund. So the intent of today is to not only hear from the vendors, but also hear from Minnesota about what the activities are for that pooled fund, hear from the agencies interested in participating in that, and really drill down on that pooled fund and what we can accomplish, along with hearing other NDE technologies and what's going on for asphalt pavement. I do want to have a special thanks for QES for organizing this event. We wouldn't have had it, but we did have a little bit of extra money in their contract to make this happen. So special thanks to QES, especially Steve Kozer. He's been working countless hours now, along with Minnesota DOT for organizing this event. We hope you enjoy it today. We hope you find it beneficial. And, thank you again for attending. Thanks, Steve.
Okay, thank you, Steve. I also wanted to make two other comments about the session is being recorded, so you should all be aware of that. And also, I put a hyperlink in the chat for those who are interested in applying for professional development hours or PDH credits and certificates. There's a little mess up with our logo on that site when you go to it. But if you fill out the information, we will electronically send you a certificate following receiving the receipt of your request and today's session. So just wanted to let you know that that is available for those who are interested in those credits. Okay, so moving along to the next item on the agenda is a recap of the September 28th and 29th peer exchange with the action items, and that will be presented by Dennis Morian. Dennis is a consultant. He was active with QES. He was the actual beginning owner of the QES, and he facilitated the session that was held last September, that peer exchange, and he's going to cover that this morning through a presentation. So let me get to his PowerPoint. Can you see this, Dennis?
Yes.
Okay, take it away.
All right. Good morning, everyone. As Steve said, we're just going to do a quick recap of our previous meeting last year for the purposes of refreshing our background of where we've come from and lead into where we hope to go today. Next slide, Steve. So the Pure Exchange group set up under the RO6D Sharp project had some identified purposes that we went over to share information about asphalt pavements and the use of NDE technologies. What's happened to these efforts since the RO6D, and to focus on the delamination and moisture segregation issue with this particular offshoot of the RO6D, and to be able to capture experiences of others and advances in the technologies the vendors are making. Next, Steve. The objectives included having a recap of the actual last RO6D meeting in August of 2018. Share agency experiences, and we'll quickly go through those and identify the advancements that vendors had made since 2018, and we'll summarize those again quickly as well. Next. Identify gaps, hindering advancements, specifically focusing on system improvements, research needed to fill those gaps, and identify strategies to continue the progress of the effort for NDE. Next, Steve. So we started out with a recap of the actual RO6D research work that was presented by Mike Heitzman, who was the PI on that effort, and provided us a very good background. We'll quickly recap some of that. So the goal is to identify and develop NDE technologies that can detect delaminations, operate at reasonable traveling speeds, and capture data from a full lane width. 3 NDE technologies that were identified during that effort was ground penetrating radar, the impact echo, and the spectral analysis of surface waves. Coming out of that effort, the most promising technologies were determined to be the 3D radar, which is now Contour, and Olson Engineering's work with the impact echo spectral analysis of surface waves. And that effort was completed in 2013. So this slide just shows a couple illustrations of how we see moisture damage or stripping in asphalt pavement layers. Next. This one, and probably most of you are familiar with this, is the gray band signals that are used to interpret ground penetrating radar, and as indicated by the arrows, some indications that stripping is showing up in this signal. Next. So quickly to talk about some of the vendors involved, GSSI participated to look at things like delamination detection, layer thickness, subsurface conditions, and void identification. Next. 3D radar presented, or now Contour presented, this version of a prototype for capturing full lane width data using 3D radar systems. Next. And this one shows the impact echo sensors, sensor device that's used to create and collect the response from the impact echoes. There was some development work taking this forward with the focus on increasing from single point measurement or single line measurement to broader width measurement across the lane. Next, and we see that here where we've got multiple data collection devices mounted on a bar that can travel down the roadway. The constraint still seems to be that the speed of forward progress for this data collection is pretty limited, unless we find out that there's some new development here today. So Mike Heitzman's summary said that the vendors need agency interested to support their development in the systems, and the agencies need implementation or implementable systems before investing in the equipment. So we have this kind of need from both sides of the issue that each depends on the other side. So that's one of the big values in having these peer groups together, so that we can talk about those, focus on those, and learn from each other as we go forward. Mike concluded that both technologies, the GPR and the impact echo and SAS waves, have strengths and weaknesses. They can be used for multiple agency evaluations of pavements. Seemed to be most useful, at least at that time, for project development, and not so much ready at that time for system-wide analysis. Both technologies need better automated analysis software. A large amount of data is produced, and it's difficult for the users to deal with that unless there's a tool to help manage that data and to make it useful. And at that time, the return on investment seemed better focused for rehabilitation projects, with the emphasis on getting better data in design and limiting change orders that happen in the field because of minimal information that we've had historically. Next, Steve. So we had a series of agency presentations. Eob from Minnesota, Darlene from Texas talked about Texas and New Mexico experiences. Brian Diefendorfer talked about Virginia experience, and particularly with the TSD. Guanming Wang talked about the efforts Florida DOT's making with NDE technologies. Bill Owens talked about the experiences and the history of effort with GPR that Caltrans has. And finally, Brad Rister at the University of Kentucky did a presentation on Kentucky's experiences. So we'll just quickly have some simple examples from each of those presentations. For example, this was Eob's presentation of the work he's doing on identifying stripping and the road doctor equipment that he's using as part of that effort. Darlene talked to us in a very interesting perspective about how TxDOT combines different NDE systems to collect information that helps them build a better picture of the conditions in the pavement and how it's being used in their project development. Brian talked to us about his work with the TSD and VDOT's experience in using the TSD, which is very interesting information and something that people have been working on for quite a while now, about 30 years. So it seems to be maturing and coming to a useful situation. Juan Ming talked to us about the different types of devices that Florida has worked with and are trying in their efforts to collect better pavement information. Several are listed here and some photos of their efforts. Bill Owen talked about the Caltrans experience with the GPR. They go back a couple decades and have been working with this for quite a while. A lot of their work has focused more on the assessment of concrete pavements, but it's still the application of the GPR and interpretation of those signals. And finally, Brad talked to us about the work that has been going on in Kentucky and pointed out that early on in the RO6D, they got the 3D radar sensors, but they had to develop their own system for mounting the device to collect data on the highway. So that was an interesting and somewhat unique aspect of what he came up with. We followed that with presentations from the participating vendors, from 3D Radar, Jacopo Sala, Larry Olson from Olson Engineering, Rob Sommerfeld from GSSI, Ken Mazer from InfraSense, and Timo Serencato from Road Scanners all talked to us about what they've done, the progress they've made, and what's going on in their particular sphere of this technology. So we'll scan through those again quickly. Jacopo introduced the 3D radar system, which includes collection of data at highway speeds, data processing system for the three-dimensional data, and how the technology and product components come together. Larry Olson gave us an overview of his development of the impact echo and spectral analysis of surface waves and the development work they have done, and their ongoing efforts to continue to promote and improve that technology. Rob Sommerfeld talked to us about what GPR is, how it's used in determining layer thickness, void, subsurface, use for subsurface evaluations, and numerous other applications. Ken Mazer from InfraSense talked to us about the discussion of technologies, including GPR, 3D GPR, and the TSD, with applications for pavement management, pavement rehabilitation design, use in place recycling, density quality assurance, and failure investigations. And finally, Timo Serencato talked to us about the Road Doctor vehicle that they use for survey and the multiple technologies that have been incorporated into a single vehicle to pull the data together and get better interpretation of the various component parts. We then followed that with a discussion of current and future needs and identification of gaps. We looked at questions including what research is needed, what improvements are needed to promote widespread use, where do we go from here, and what kind of support level is needed to continue to move forward with this technology effort. So we talked about what steps do we need to follow to properly advance the GPR and the IE SASW. The discussion focused on continuing the user group, which is the purpose, as Steve said, of what we're doing today. And to emphasize for today's discussion efforts related to stripping detection in asphalt pavement. We talked about possibilities of how support can continue for this effort, and as Steve Kozer said, that the Minnesota is leading a pool fund specifically devoted to this particular objective. Next slide. So we talked about strategies and how the individual areas of NDE applications should be identified. Those applications include use in planning, design, construction, and quality assurance. Several tasks were identified as being needed to continue to move this forward, including methods for equipment calibration and renewal, development of standards for various applications, development of automated data processing analysis tools for various NDE applications, compilation of the experience for the use of combined NDE technologies, and how user training should move forward, including basics of GPR technology and data analysis methods and use of tools. So from that, the discussion culminated with the following action points being identified to host another user meeting, which is today's meeting. And it is a virtual meeting, as we discussed. Maintain focus on pavement applications and in particular, focus on, put additional focus on the moisture-related damage identification in asphalt. So I think that pretty much wraps up the quick summary of the previous meeting we had last year.
Does anyone have any questions for Dennis? Just wanted to also mention that you can use the chat function to post any questions that you don't want to ask out loud, or if you want us to try to address them. Okay. So moving back to the agenda, we have Minnesota DOT talking about their NDE. I'll let Eob clarify the research, but it was what they've done in 2022 and what they're doing with regards to 3D GPR for project scoping. So with that, I'll try and load up your presentation here, Eob.
Steve, is it okay if I share my screen? I have too many animation.
Okay, let me, I guess I'd stop sharing. Okay, do you have control now, Eob?
Let me try again. Okay. Do you see my screen?
Yes.
The full screen?
Yes.
Okay. Good morning, everyone, and thank you for making the time to attend this meeting after Thanksgiving. Before I start, I would like to thank Federal Highway and Steve Cooper for sponsoring and for giving us this opportunity to have this discussion. I would like to thank QS and Steve for really helping us prepare this meeting and keeping us in track, and also for facilitating many excellent conversation with vendors and other states. Thank you. And I would like also to thank Mindat for continuing to support this this type of innovative technologies. So today I plan to give you an update on the pool fan study on using NDE technologies for stripping. I will outline the objectives and also the scope of work for that study. But before I do that, I wanted to share some of the experiences, some of the Mindat experiences, some of the efforts that we are doing to incorporate 3D GPR in Mindat project scoping process. I am sure that at the end of this presentation, you will see that these efforts tie very well with the pool fan study. And what I'm hoping to convey to you is that this study, what we're trying to accomplish through the pool fan study, will also have immediate application on your state DOT's daily routine applications, like for project scoping or payment evaluation. So let me start with the first introducing what is the Mindat's road doctor program. Let me just move once. Okay. Before I do that, I would like also to acknowledge my team, which has been fundamental in providing the data that I'm going to present, including my supervisor and managers, Daishong Tao Jia Brunner, Thomas Calhoun, Logan Scaff, and former employee Avra Priya. I also thank all the Mindat staff that have been helping us with all these projects. So what is the Mindat road doctor? As it hinted in the name, the road doctor, it was basically inspired by Road Scanner's road doctor. In 2019, we purchased almost all the softwares and the hardwares in the Road Scanner's road doctor, and we built our own road doctor. Here I'm showing pictures during the construction, during the building of the van. So the reason we needed to do that is because we wanted to create a system where we can store all the equipments in the van and decide on a project basis what equipment to use. We want also to make sure that the equipments were safely secured during all the Minnesota seasons, and enable us to perform testing at normal traffic speeds. Here you can see the road doctor during winter on the left side, in summer, Minnesota summer, during night or day. So this was the road doctor that we built for Mindat. So what is interesting about this road doctor survey system is that it has multiple sensors that are linked to one navigation system, so that you can basically connect, link, or fuse the data fusion of all these sources to have a better understanding of your payment condition, both on the surface and also in the subsurface. So the three main computers, control computer that we have, data collection control that we have in the van are Camlink, Road Scanner's Camlink, GSSI SIR30, and Contours Geoscope. The Camlink governs almost most of the sensors, including the positioning and navigation system, GPS, IMU, and DMI, two high definition video cameras, a thermal camera, and an accelerometer for roughness, ride quality, and the LiDAR scanner. The LiDAR scanner, as you can see, is on the end, on the back of the van. The SIR30 controls the two horn antenna in front of the van, you can see here, and the ground couple GPR antenna. The Geoscope controls the 3D radar antenna that we have. As you can see, the van is designed to accommodate both the GSSI antennas and also the 3D radar or contours antenna. And the gyroscope controls it. For data processing, we use road ductor and examiner softwares. The road ductor is suitable for processing all the data obtained, collected using the system, while examiner is more suitable for the GPR, 3D GPR analysis. And it can also, you can also load the video image so that you can have use it to help the interpretation of the GPR. So before I talk about how we use this technology, let me please allow me to take a brief deroute and explain some of the challenges in adopting innovative technologies in the payment industry in DOTs. Through my experience, I have seen, although still very young experience, but I have seen a lot of excellent research, innovative technologies come out from research and development, but fail to track enough attention to move on. So ideally, once these tools come out from a research development, they would transition to DATs or to road owners, to road authorities for implementation. But most of the time, this transition is not that smooth. And in the years I have collected, talking to different engineers, some ideas of why this could be a problem for DOTs. Of course, the first one that comes to mind is the cost of technology, how much most of this innovative technology, sometimes they could be expensive for some DOTs to own. And for consultants, unless you don't know, you can make profit out of that when they are at the early stage is too a risk investment. So the cost of technology is an issue sometimes. And as you can see, I highlighted the staffing because the purchase of hardware, software, or the license, they are predefined, you know them. But what you don't know, the unknown, is how much it will cost you to have the proper staffing, the training, and all of that. The second that I hear a lot from engineers, from DOTs, is I kind of have the sense that DOTs are risk-adverse organization, and rightly so, because they are dealing with safety, with the budget of taxpayers, but also technology maturity and performance uncertainties are also of concern. So typically what I see with innovative technologies is some states decide to wait for other states to implement them before they jump on the train. The other is also what will be the relationship between these innovative technologies and existing practices. Do these technologies replace or supplement existing practices? And also, are the current standards valid, or do they apply to the new technology? So this is another type of question that kind of obstacles the quick use of innovative technologies. And then also the lack of user group support. The user group support, especially on innovative technologies, are important to disseminate information and build confidence to engineers and end users, so that they can have enough confidence to try them on their project. So in some of these technologies, we do see that there is a lack of user group support, and that is what we're trying to do with this pool fund study, but also what the R060 does. And then also there is a question, where is the proper housing for this type of technologies? Once you bring it to your organization, where do you put it? Do you put it in the bridge office? Do you put it in the construction office? Or where is the proper application so that you can make the best use of it? So this is another concern. And one important concern, especially with these new technologies, is that most of the times innovative technologies, they produce huge tons of data, but that data does not necessarily mean information. So so it is important that the organizations work on the data to extract meaningful information that address the specific concern of the end users, of the engineers. And for this, you need also to have customized template reports that match very well with existing standards and practices. Finally, is also the question of scalability. How can you scale up this type of technology? Will you be able to use this technology on all of your projects or some of your projects? And how do you make those determinations? These are some of the questions that sometimes obstacle the smooth transition of innovative technologies to implementation. As I go, I will be keeping track of this type of challenges. If you have some, please let me know, or if you want to comment on those, modify or make some suggestion on this, please let me know. So with this in mind, with this type of concerns in mind, we in the last 4 years we created the Road Doctor program, MINDAS Road Doctor program, and the Road Doctor program was placed in the research office under the Office of Material and Road Research, so that it can serve different customers. And what we do is first we learn the tools, and we've been building a team. And then we've been exploring application for this type of technology. As you can see here, we do work with our research partners, LRRB and RRA. We do conduct our internal research. We work with bridge office, with district, and other. So some of these customers, once they hear about the technology, or if they heard it somewhere else, they will come to us and ask, can this technology be applied for this specific problem? And what we do then is we work with them, we do some research, to see if this technology can be applied to help them solve their problem. So to show you some example, we do work a lot with district offices. Some of the work that we do is to use the technology for project scoping. We've been working a lot to build 3D milling thickness models for automated milling, or what they call the machine guidance or variable milling depths. We do use the system for root cause investigations, and in the concrete payments, we do use the system. We're trying to use the system to check the alignment of tie or dowel bars, and also to look at some joint delaminations. We're trying to see if this could be applied and how can we apply it easily. We do also conduct our own research. We did some 2 years long research for tenting, for GPR moisture, using GPR to measure moisture in the aggregate in the foundation of in-service payments. The PF full fund study is part of this effort. And then we are also looking into some machine learning tools to analyze some of the data, especially the video image that we're getting from the system. A typical approach that we use once we get a request to try some application. First, we do some research to see similar application by other states or other DOTs or other road authorities, and then we conduct a few pilot projects. We develop a testing and analysis procedure. And then we try to see what is the relationship with existing procedures. Do the standards apply? How do you replace the current procedures? Those kind of questions. And then we try to talk to the customers, in this case, most of the time to the districts, to build confidence, to provide information on the limitations and capabilities of the testing technology. And once we have consensus, once we have enough buy-ins, we start developing a guideline for implementation, and then we scale it up. So I will show you how this provides some case study examples, how we've tried to do some of this. So, but before, let me so far in these 4 years, we used the system, the Road Doctor survey van, to collect around 1,000 miles in all in Minnesota. Here is the picture of all the roads that we tested. So we've been almost everywhere in Minnesota. As you can see here in this chart, the more we know about the technology, the more we learn the technology. We've been able to basically double the rate of testing every year. And also here, this is also an interesting chart because it shows you the districts that they work with this technology, they quickly realize the advantage of this technology, and they come back again because they do see the advantage. The districts that have worked little with us, they are the more conservative, but the district that had initially worked with us quickly, they are wanting more and more of this type of technology. So what I am hoping to convey here is that the technology, what we're trying to study in the 3D GPR application, although the pool fan study is mostly strictly for stripping and moisture-related damage, but it has also a lot of other applications that could be useful to other state DOTs as well. So just to give you some of the examples of the research studies that we are conducting, one of the early studies that we did was using the road ductor, especially the data fusion capabilities of the road ductor for studying tenting on Minnesota pavements, especially on the colder region pavement, tenting or crack heaving studies. So I won't be able to give too much information on this, but if you are interested, we do have a published paper on it here on the left, or you can send me an email. We can talk more about it. But some interesting outcomes from the study was, for example, here I'm showing you two sections. That one section was relatively in good condition. So tenting, the first thing, the major impact of tenting is it affects the ride quality of the pavement. As you can see here, this section, it has around 2 IRI, which is basically a good section, very good section, almost new section. And then here on the contrary, the second section, it's almost 4 times higher IRI, which means very poor ride quality. So what we saw interesting is that this poor ride quality or this type of issues, they were also reflected in the surface temperature collected from using the thermal image data. As you can see here, the rough section has more thermal segregation, and we do believe that this very hot pocket of areas are also due to salts used during the cold season. But also we saw that the GPR moisture damage index obtained from the road ductor software also showed that the section which was highly affected by tenting or crack heaving has also more moisture and frost activities on the subsurface. So both in the surface and the subsurface, these two issues were connected. And then finally, by analyzing all this data coming from IRI, elevation profiles, GPR, we were able to provide some rapid testing procedure for locating and characterizing the pavements affected by tenting. We do often use the system also to detect sinkholes or voids under concrete. This is not always successful because depending also on the type of pavement, some of the concrete pavement, they're highly reinforced, or it could be the pavement condition do not allow it. But most of the times we've been able at least to pinpoint areas or suspect area that you can do further investigation. We've been doing sinkhole detection both before and after grouting, just to see how effective is this application. We did see though the ground couple antenna is better suited for this type of application. Here I'm showing you an example where we're trying to see if the 3D GPR could also be successfully used, effectively used to check the alignment of tie bars or dowel bars. Another example is the research study we conducted in the mill road cells for over 2 years now, using the GSSI ground couple antenna at the beginning. So what we saw, what we are interested in, if the GPR can be used to basically measure or assess the moisture content in the foundation of in-surface pavement, to see the moisture fluctuation in the season. This is useful for many ways. One is because for us it's important to see how to measure the moisture fluctuation, especially in March. in the spring thaw period, but also this could be a very useful tool to see to find areas that could be easily affected by stripping, because the more moisture you have in the pavement, or the more moisture susceptible pavement you have, that will be likely also create a good platform for stripping. So here the chart shows GPR estimated volumetric moisture content compared to in-place sensor estimated moisture contents. So as you can see, we did see very encouraging results. We published these results in a TRB paper, and also another paper where we saw the relationship between the GPR indexes and falling FWD indexes. Currently, we're working with Contour 3D data, trying to see if the same thing can be achieved also using the 3D, the full length 3D GPR ground couple antenna. So with that, I would love to talk to you a little bit more on some of the efforts that we are, some of our efforts to incorporate 3D GPR in MinDAT project scoping process. In project scoping process, the main task is to gather key engineering data that will help us select the proper rehabilitation for our pavement. The two main information are the thickness variability, both in the longitudinal and transversal, and the structural adequacy of the pavement. You want to make sure that the pavement is strong enough, or the remaining of the pavement that has not been rehabilitated is strong enough to support the new traffic and also the construction equipment. Here I show you, for example, the cold if you decide to use a cold in-place recycling or a white topping option, it is it's important to know the thickness of the AC layer in order to determine the proper target mill depths, but also it's important to know if the remaining pavement will have adequate support, adequate bearing capacity to support the construction equipments and also the new pavement and new traffic. So this adequate, structural support does not come only from, is not only a function of thickness, but is also a function of the quality of this remaining pavement. If this remaining pavement is deteriorated, if you have a lot of stripping, then you will be forced to reconsider your rehabilitation. We've seen this in many of those projects. Some of the projects that we do, they start thinking they could do CIR, but then they find that the pavement is completely deteriorated, so they have to do some other type of rehabilitation. Here is another example of why is important the thickness variability here in full depth reclamination. In that case, you need to make sure that you find the proper target mill depths that will give you optimal asphalt binder to aggregate ratio. And here is another picture that just to convey the information that also the transversal variability are important. We've not been paying enough attention on the transversal variability because we didn't have the tool. But now with 3D GPR and this new innovative technology, this is also becoming a focus point. So far, we've been doing this, we keep doing this using traditional project scoping tools like coring, boring, FWD, and skid. And but these tools, they do have some important limitation. One, especially the coring and boring, they are destructive. But the main limitation, these are discrete spots. These are tests taken at discrete spots, taken randomly, blindly. You don't know what is going beneath that pavement. So it's very likely to miss critical deficiencies or to over or underestimate the extent of these issues. And then the other concerns are also they do impact negatively traffic flow. They come also with safety and cost concerns both to the public and operators. So because of the impact to traffic and also to impact to safety and cost, you are kind of constrained to how many of these tests you will be doing in your project. So because of this, we've been trying to improve these practices using some of the innovative technologies. One easy, quick advantage of 3D GPR is basically to use the 3D GPR images to basically guide the coring boring practices in our project scoping. We don't necessarily have to replace them because you still need the coring and boring to kind of have a feeling and see visual understanding of the material. But you can do this strategically by collecting coring boring in where is needed. For example, here I'm showing you a GPR image where basically it's clear image. You do see the interfaces of the two layers are clearly visible, and the pavement is very homogeneous. So you don't need that many coring. You will just need few corings for maybe for calibration and just to see what is going on beneath there. On the opposite, then you see here sections that they may require more testing, more GPR coring, or you can basically strategically select these areas for coring so that you know what is going on here. So if we have done this randomly every 1/10 of a mile, probably we would have missed these sections and we would have collected, or we will have generalized what we saw in these sections to all the road. So this type of what I call here intelligent coring has been very helpful to us to reduce the number of spot tests. We can also use this information to prioritize which lane to core or which not. This is also reduce the impact to traffic and mitigates the safety and cost concerns. Some example, this is an example, a recent example on Highway 35 in the metro area here in Minnesota. As you can see, most of these roads that are planned candidate for rehabilitation, they are very old, 50, 60 years old. And most of the times, a lot of times, we don't have all the documentation necessary for this type of payment that have seen several major interventions throughout the years. In this case, this payment was subjected to numerous mill-end overlays. The median was replaced to inside lane. They created a min-pass lane only in the northbound and add an auxiliary lane in the southbound. So you can imagine how some of this information maybe get lost in 50 years or 60 years almost that we've been there. So when the engineers approached us to kind of analyze, evaluate this pavement and see what is going on beneath in the subsurface, we use the 3D GPR and we use the intelligent coring. How we use the intelligent coring. So as you can see here, I'm showing you 3 different lanes of the pavement. We saw that the first thing we saw that, for example, the middle lane and the outside lane, they were almost completely similar. So there was no need to have cores taken on this mid lane and add additional burden to traffic. So we between the mid lane and the outside lane, we focus most our coring only in the outside lane. And then, as you can see here in this first southern portion of the road was pretty much uniform, homogeneous. We clearly identified the lanes, the interfaces. So there was no need to put too many cores in there. On the other hand, on the northern portion of the road, we did see some certain strong anomalies that we wanted to test. So we had more corings performed on this area. The result here is the result of the study. And here we were, as you can see here, we were able to pinpoint all the transitions from, we were able also to see different pavement structures. As you can see, these transition points are not easily achievable using coring or boring. But most importantly, we were also able to identify sections that were not previously well documented. So the engineers were not expecting to see a 13-inch bit on this end, and on this other end of the road, but also this 13-inch full depth bitumen. So this is kind of how the new technology can supplement and help the existing practices. Another effort that we've been doing, at the beginning, I told you, how do you get all this data and transform it into a template that engineers can easily use to extract important information for them. So what we've been doing is we've been creating some macro in Excel macro templates for engineers to use and to read the GPR, 3D GPR results. So these macro Excels, basically they are given to them, and they are helpful in to see what to kind explore what is the right milling depths. So basically here I am showing you, this is the road here, 2 lanes of the road, and here is the milling depths. If you, what this chart is telling us, if you cut this road at around 6 inch, basically this is telling you that you will be cutting on the top layer, on the asphalt layer. So you want, if this is what you want, you will be ensuring that you're cutting only on the asphalt layer. Otherwise, if you move that 6 inch, here I change from 6 inch to 13 inch, this is what will happen. You will happen that you will be cutting almost close at the interface between the asphalt and the aggregate base layer. And some of this area, you will be, some of these areas, they will be very dry, very dry. They will be, they will have more aggregate, and some of this area will have, will have a lot of asphalt and little content of aggregate. So if this is what you want, it's good, but these are options that you can have. You can play with there and see what is happening in your road, both in the longitudinal and transversal area. So these are some of the efforts where I discussed before, how do you get all that tons of data and then convert it to information that engineers can use in their project scoping documentation. And then here, finally, I would like to discuss some of the studies that we've been, a case study where we are using 3D GPR to assess pavements affected by stripping. Not all, this is very kind helpful for the pool fan study. This is kind why we think the pool fan study can be achieved, accomplished, and why is it important. So here is a case study. We've been working on it for the last 3 years. What makes this project interesting, it's on Highway 71 in Bemidji, Minnesota area. So the pavement was first built in 1977, and it was a road mix, which is a asphalt mix prior to super pave, very susceptible to moisture, over a natural grade clay. And then in 2002, the top portion of the asphalt was replaced with a newer superpave HMA and the PSB, which is a more permeable asphalt pavement type of sort. But then very quickly, the pavement is completely deteriorated now, very rough. So they are going to replace it. So when they went out and cored, they see this is the type of core they get extracted from the turn lanes. As you can see in the turn lanes, they were able to extract the entire bituminous layer. Here you can see the old road mix. This is the PSB, and then the new superfab HMA. Unfortunately, in the mainline, almost everywhere, they were not able to extract by coring the entire bituminous layer. The reason for that is that because the old pavement in the mainline, where you have also traffic, was completely deteriorated due to stripping. So they were able to extract only this top layer, the newer asphalt bituminous layer. So here is, for example, the coring results. The black bars are from mainline. The cyan or the blue are from the third lane. As you can see, the only time they were able to extract the entire pavement bituminous layer was here around 333 RP, and that was because that pavement section was recently completely reconstructed. Otherwise, they were able to extract only the top layer. So how do we know there was something else here? Because they went on and they did boring. As you can see in the boring, they were able to extract all this material, and then they found out that most of the times this material is also deteriorated due to stripping. So faced with this problem, they reached out to us and tried to see if we can at least give them the layer interfaces, the thicknesses for the pavement with the 3D GPR. So, and that's what we did. But on top of giving them the layer interfaces of the top and bottom, we also tried to come up with some methodologies for us to assess the severity of stripping on all the pavement sections. We divided the pavement into 1 mile length load. As you can see, here is an example of a pavement section which is in a relatively good conditions. Here you can see the top layer and the bottom layer, and both of the top and both layers are very homogeneous. You can this is a clear image. You can easily distinguish the layer interfaces, and you don't see a lot of noise. By noises, I mean these are the main reflection that we're expecting. We are expecting reflections at the interfaces. If you see other reflection between the interfaces that they were not supposed to be there, that's what I'm referring to noise. So here we don't see a lot of noise clear. Compare that to a section which is highly stripped section. Here you can see you can see the first layer interface, but it becomes very difficult to see the other layer interface because there is a lot of stripping, a lot of noise going on. So we try to use this image, this type of image. Okay, this is a qualitative. This is basically a visual examination of the image. What we try to do is, okay, how do I transform this visual examination information into something quantitative, something that can be converted into numbers and compared to other payment information. So here I give you, we did some research. There is a lot of research going on there that Tom Scullion have done some wonderful research on that. Ken Mazer has done some wonderful research, Louisiana DOT. So we did some research, and this is what we came up, what worked for us. So basically, we took out the 3D GPR data and we created a algorithm for handling that 3D GPR data. So this is an idealized reflection of the GPR. See, this is, if you don't have nothing going on here, this is what type of information you would be expecting. But if you have something going on here, you would be seeing a lot of noise that will basically take energy or take shadow the other reflections here, the main infractions. So how do we transform this into a quantitative measurement? So by doing some of the research, one thing that we saw is that the positive reflections, they were related with stripping. There are some research that shows that the positive reflection, they are related to stripping. So what we did is develop an algorithm in Python. So, and that algorithm, it was designed to, first of all, to load, import 3D GPR data, and then to handle each of the traces, each of the A-scan separately. And some of the analysis that were made on each of the A-scan were to identify the peaks and troughs automatically, and then basically propose or compute a damage index. In this case, we decided to use the sum of positive reflection. We did all this analysis in time domain. There are others that also include in frequency domain, but for us, we found this was an easy way of doing it. Basically, the sum of positive reflection from each A trace. So once you do this for 21 channels in 3D GPR, then you can produce a 2D heat map that tells you, okay, what is going on. If there are areas where you have a lot of high positive reflection. By the way, this positive reflection, we were focusing only in the layer, in the specified region, only in the layer that you decide. You can decide to go to look at the entire bituminous layer, or you can just focus on the second layer, because this is where we know there is a lot of stripping. So if you do that, you would come up with a heat map that will tell you, okay, this is the type of information. And once you found that threshold that tells you, okay, this could be an area suspect of stripping, you can start building these heat maps that identify sections that they may have stripping. In this case, this section 324 to 25 was a relatively good pavement condition compared to the other. So here you don't see a lot of anomalies on the pavement. Compare that to this one, where you start seeing, okay, there may be something going on in here, and then compare that to this one, where you have basically almost everywhere there are areas that may be they may have strong stripping activities. So by doing this type of analysis, and then you do it for the whole project, you can identify the area where you have major problem, and you have areas that you may have a little bit, relatively little bit of problem. Then you can use this information to basically optimize your rehabilitation rehabilitation or repair treatments. But we didn't stop here. We went on because we did have also FWD data for this payment, and we did try to see the stripping indexes from the GPR that we created if they were somehow related to what we see from the FWD. And why FWD? Because FWD, when you have a payment which is highly stripped, that means you also the bearing the bearing capacity of that payment also falls down. So here, this is a payment that we saw this was in good condition. As you see here, and here are the FWD deflection basins. As you can see, the taken every 1/10 of a mile. This is a 1 mile project. As you can see, yes, there is a little bit of variability between the deflection basins, but they are very much consistent. They are similar, and they go at about 150 micron. Compare that to a section that was shown by the GPR image to be stripped, highly stripped. Here you can see the sections. First of all, the basin deflection, they were highly variable among themselves in homogeneous pavement, and also that you start looking at numbers almost double the rate, 300 at the center of the plate. So now we move on and we try to see if there is a relation. Clearly, so there was a very strong relationship between the sum of positive reflection that we saw there and the deflection at the center of plate. So this is by no means this is not the end of it, but these are encouraging results that can be useful for the pool fan study. These are results that encourage us or ensure us that what we're trying to achieve with the pool fan study, it is doable. So with that, this is the first part. So I thank you, and if there are any questions.
I've been looking at the chat function. One comment was there's the lack of standards and specifications. Training and education could be added to your list. I think that was up probably around the first handful of slides. And then standards for both data collection and data analysis, presentation and interpretation. Is what the one comment was. And then somebody asked about, are the slides going to be available afterwards? And the session is being recorded, and we are planning to, the intent is to post the recording on the QES website following today's session, and we were going to send a link to all the participants today so that they had that opportunity to see that. Okay, so
I can comment on the first comment. Yes, thank you for that comment. Yes, the lack of standard for data collection, data processing, that is an important objective that we want to accomplish on the pool fan study. We would like to come up with a standard that works not only for Minnesota, but that works for nationally, that is agreed nationally. Yes.
Okay, I don't see any other chat questions that came in, Eob, so you can go on to your next presentation.
Okay, you want me to start now?
Yes, please.
Okay.
Well, yeah, we just want to remind you about 7 minutes left. Sorry.
Oh, okay. So I think we do have another time for the next presentation on the pool fan study, right?
Yeah, that one went over about 25 minutes.
Oh,
So
sorry.
I think what Di is saying
So-
is you've chewed up a lot of the next session time.
Oh, sorry. I apologize. So I will quickly go to the
pooled fund study.
So I will quickly go to the pool fund study. So a quick update. So far, the pool fund study has we have 6 agencies that have committed. 2 states, Wisconsin and Georgia and Kansas, that are expressed interest. They are following it, but they have not committed. And so it's now cleared to start. And these are the states that have committed to the project. So it will be nice to have 1 or 2 states also from the West and East Coast. So in the interest of time, I apologize, I will go quickly over. So when we created the proposal for this pool fund study, we start from the recommendation of R060 and TAP studies. And we had several meetings between us, MnDOT, and Federal Highways, and then we send a proposal for review and comment from other experts. We heard from Mike Hensman, Ken Mazer, and other engineers from Interest DOT. So we try to put there most of that information. So you are aware of stripping, and I kind touched on why. So one question that we received when we were trying to, during the solicitation, to try to reach out to states, one of the questions that sometimes we were hearing is that, is the stripping still a serious pavement threat? Because we do have super paved performance, anti-stripping, poly-modified, proved drainage practices. But unfortunately, yes, it is still, because one of the reasons is because we keep building on all mixtures. The old mixture are still beneath the new mixture, so the old mixtures are susceptible to stripping. We are using more and more recycled materials. Sometimes we are recycling the pavements even 2-3 times, and then lately we are using core recycled mixtures. They don't have the best quality. They use emulsion, not the highest, newest type of binder. And then we do have also composite pavements where you do see stripping at the interface between the concrete and the asphalt. And some we do also see, unfortunately, some contractors toying with super variables to use less binder. So because of this, stripping is still an issue. I talked about how these are traditional tools are kind of limited. But what we try to do with innovative technologies, like what we do with a doctor, you scan the pavement and try to find the area where you need to investigate. So that's what we're trying to do with this pool fund study. This is the previous study where we came up. The 3D GPR is very suitable for this type of study for so many reasons. One, because it collected the traffic speed, and then it has different frequencies that you don't have to select which antenna is proper for this type of application. And then it's really very implementation. Many states, I mean, some states, they are already applying it. So why not focus on 3D GPR? So this is a new pavement, just recently paved. This is what type of pavement you will see when you do 3D GPR. And then when you go to a pavement that is completely stripped, you would see something some image like this. So what we want to do is how to kind of locate the extent and depth of severity of stripping immediately. I mean, in a rapid, in an automated way. So just for clarification, this study will be focused mostly on the 3D GPR, but we will use also other NDE to validate what we see with 3D GPR. So there won't be any overlapping with the other TSD program, for example. So what we will do is that we will use the 3D GPR, and because we know the 3D GPR does not necessarily work at all conditions, we'll try to validate it with coring, boring, FWD, impact echo, TSD, all available. And if we can make sure that all this information, they tell us something about stripping, that is also a welcome outcome. As I said before, this is not, we would have some early result that encourage us. This is a study from Ken Mazer trying to, again, this is also energy meter mean data effort from the previous study. This is the current mean data effort, relating it also to FWD data. So we do have some very early promising results. So now, we hope, we plan to have a project kickoff meeting in February, early February. So there we will be discussing the project charter. We will revise, and before the meeting, we will send the final project charter and the scope of work to all the participant states, and so that they have time to review them. And then during the project meeting, we will revise and approve the project charter, and then try to create a working group. If any of you is interested in participating in the technical working group, please send us an email. You can send it to me, to Dai, or to Steve Cooper. We will we'll update you on the meetings. So yeah, and then it will basically the start of the project. So these are the proposed for the trial. The first thing that we'll do, it will take some time, enough time to finalize and work the details of all the tasks that will be in the project. So we will work out the details. We'll finalize the time and budget allocated for each task, and then we will solicit interest and identify qualified respondents to accomplish each of these tasks. So if you are interested, again, it's please let us know so that we know that you're interested, and then we will update you with the meeting timings and everything. And then the second thing that we will do is a literature review and administer a survey. So a survey is very important, especially we will administer the survey to the participating state. The reason we do that is because we want to know what type of stripping they have, and then what is their expectations from this project. Then we can do a literature review, which is basically that emphasizes on the stripping mechanism of the states. And we'll also do a synthesis of the NDT technologies. And then through this survey, we'll also identify road sections from each state to be considered for the study. And then the third, we will create a GPR stripping signature database. This is very important because most of the times when you are interpreting the GPR, you don't know what type of traces are related to what type of stripping. So this is a similar effort by Darlene in Texas, and then this is another numerical model based by Ma and El Sefi from Louisiana. So what we want to do is build on this and expand different type of geometries, different type of pavements, and try to come up with a database of these are the type of GPR that you see when you have stripping or other moisture-related damage. We plan this task will include analysis of existing 3D GPR data, laboratory experiments, numerical simulation, and static field tests accompanied with scoring data. And then there is another section where we'll have artificially stripped section in Mill Road that will be used again to validate what we see in the laboratory, but also will help us develop an algorithm for detecting stripping. And then the most important part of it will be the creation of a software that for automated detection of stripping, creating a quantifiable GPR stripping index, and then linking the GPR data with other NDE, provide the result in a geographical map, geo-tabulated output, and then produce a user-friendly software packages. This will be one of the most welcomed outlines, because we would like to come from this pool fund study with with a product that states can use. And then once we have the algorithm and the testing procedure in place, we will use all this testing technology to evaluate at least 2 roads from each participant states, roads that are known to have stripping issues. So we will collect data, we will process the data, we will verify, validate the tools developed, and using this data, we will hope to come up with precision and reliability information. So the precision and the reliability and all this experience will then help us develop a specification guideline for data collection, for processing, guidelines for like the gentleman before mentioned, I was not able to read the name, and guideline for data collection, processing, calibration, all those information that are needed to use these technologies. And then we will we will also produce guidelines for implementation plan. And then we hope to provide also precision limits. And all of this, it will be wrapped up in an AASHTO standard draft. And then another important part of the pool fund study is also to have a task for training and technical assistance. We would like to share the knowledge among the states, how the states are using this technology, what are the limitations, the challenges, and then we will love to use this pool fund study to produce training materials and manuals and in-person trainings. And support and communication is also one important part of it. We will keep continuing having user group seminars quarterly and as needed calls with the technical working group. And we do have already a website for it, but we will also produce, we will keep maintaining it and updating that. Another important, it should have been also previous. This is a strategic technology promotion. So we need as a group also to try to kind of promote, refine this technology, but at the same time promote this technology, because the more we use them, the more we will have the cost will, we hope the low cost will go lower, and the more knowledge is there, it becomes easier to use these tools with confidence. So the strategic technology promotion is also another important task of the pool fund. We will have webinars, seminars with road and agencies and vendors, and then we'll try to disseminate the knowledge as much as we can with papers, reports, and other type of video materials or whatever is needed to promote this type of technology. So important deliverables, what we will hope to achieve is also a specification that is standard and agreed among many states. And then you have a user-friendly software that is for detecting stripping. So again, I apologize. I've been quick, but I hope I am back in time. So if there are any questions. Was I quick, Steve? Am I
Yes,
still good?
thank
Okay.
you. Thank you, Iyab. That was very good. And those last handful of slides are really important, and it shows that you have a well thought out study planned to be accomplished. So very good. And you picked up on some of the things that were mentioned from the previous presentation that could be included in the previous one that are now included in this. Yes.
Absolutely, yes. And we do have also a preliminary proposal in the website, but we are going to update that during this solicitation period. We received a lot of comment from engineers from DOT, so we have evolved some of our thoughts. We have included some other technologies that we didn't include at the beginning, or we have included some type of split mechanism that we didn't include, we didn't think of before. So this solicitation period has been a very useful to us. So we do have the original proposal, but we are going to also upload a newest version of the proposal so that people can read it and reach out to us. But most importantly, what I want to say is we would really, really love it if you can participate in this study. And if you are interested to participate, just to follow it, or if you are interested in accomplishing, being responsible for one of these tasks, please do send us your emails and contact information. And yeah, that's what I want to do. The more we are, the better the success of we are very interested in the success of the pool fund study. So if we can identify the best experts that can do one of these tasks, it will be very helpful to us.
Okay, well, thank you. Yep, I don't see any other chat questions added. So can you relinquish the control back to me?
Sounds good. Thank you.
Okay, can everyone see the agenda? Or anyone cannot see the agenda?
We can see it, Steve.
Okay, great. Well, now we're going to move on to hearing from a lot of the state DOTs that are involved in the study, and some that are very interested in it and just haven't financially participated yet or may participate. So we've asked each one of these states listed on the agenda that they could express their interest, talk about why are they involved in this study, now that it is a study, and what kind of questions and challenges or concerns do they have that maybe the study participants as well as the vendors could address. So with that, we're going to start off with Missouri DOT, John Donahue. John, you're with us, correct?
I am here, Steve. And also too, last week when we did our dry run, I said I wasn't gonna have any slides. I do have 3 slides, if it's okay to share my screen.
Okay, I'll give you, yeah, I'll stop sharing. Go ahead.
Okay. Let me pick the right.
And so we could have them for the future for posting on the website. Can you email them to me then later on,
I'll
John?
email you those. So
All right.
anyway,
Thank you.
yeah, I'm just a few slides. I want to talk a little bit about the importance or emphasizing the need for having standardized non-destructive test methods for evaluating strip pavements. When we do evaluations, and we've tried GPR. I mean, we've kind of dipped our toes in the water over the last 20, 25 years on a few projects, research activities, but we really haven't gotten to anything inventory wise with it yet. But when we evaluate asphalt pavements, probably the number one question we have when we're considering some type of rehabilitation is how deep can we mill, or can we mill at all? And it's really important for 2 reasons. One, contractors want the millings. They want to use it for wrap. Number 2, we want to try to keep our current profile, pavement profile, if at all possible, because raising the elevations is going to have a collateral impact on slopes, shoulders, guardrail height, bridge clearances, things like that. So if, if at all possible, we'd like it to remain the same elevation, assuming that we still have adequate structure. So for both, and this applies to both composite and full depth asphalt pavements. And I think EOP did a great job of kind of touching on the critical nature of trying to understand what the milling depth should be. This first slide here just shows you a composite pavement core we took. And I think the total asphalt thickness was probably about 4 inches. Now, we took it, you see two longitudinal cracks there. The one on the left, I'm pretty positive is probably the construction joint between the 2 mat passes. The one through the stripe, I'm thinking is probably the edge of the concrete pavement. So it's kind of a reflective crack. We took that core maybe about 4 or 5 inches from the crack. So we're near the crack, but still, right in that spot. The mat looks good, looks relatively intact, really no deterioration going on. But when you take the core, you can see that the wearing surface, while that's in great shape, that binder course in between the concrete and the asphalt pretty much just fell apart once the core was extracted. And to kind of give a more extreme case of this, here's a full depth asphalt core, and the top wearing surface looks good, although there's some stripping between that and the second lift. The second lift is kind of okay, and then from there on down, it's kind of a pretty bad situation all the way down to the whatever that was, subgrade or base or whatever was originally paved on. And herein lies the problem as far as milling depth goes. If you go too far, if you get into a milled surface, and this goes to contract, a contractor is out there removing it to the specified depth, and all of a sudden the entire thing starts to ravel and disintegrate. Then if it's a composite pavement, a lot of times you wind up milling all the way down to concrete. If it's full depth asphalt, well, you got to figure out how far down do we need to go if this is essentially going to be our pavement on a pretty unstabilized layer. How deep do we have to go? The bottom line is you wind up blowing the budget out of the water. You have huge overruns. So, this kind of emphasizes why it is really important to know how deep we can go with milling. And mentioned intelligent coring. I don't know, we kind of do semi-intelligent coring. I think we know where to core. generally. The problem is we can't always safely core in those locations. So we may have to offset at some distance, or maybe go down the road a bit to get away from a a merge lane or something like that that's occurring. And finally, this last slide here just kind of shows you the progression of stripping that happens. Now, these cores are taken 3 years apart in roughly the same locations. And whenever we take cores and we evaluate them in the lab, we split them. And what you like to see is, in Missouri's case, our primary coarse aggregate is limestone. So it's, generally a whitish color. And when you're splitting those cores, you want to see that aggregate split in half, which means the asphalt is still really adhering well to the rock, and the rock is actually the weak aspect of the mix. But as time progresses, if you split one of these cores, what you see is less of that nice white shiny surface and more discolored aggregate, where basically the asphalt peeled off the surface of the rock, and the split did not go right through the aggregate. So you can see how the core on the right is becoming much more susceptible to stripping in the near future. And that basically is it, Steve. I really don't have anything else. A picture's worth 1,000 words. So
That was going to be my comment, John. Thank you.
let me stop sharing.
Okay.
You have the
Okay.
controls back?
Should be showing the agenda
Yeah,
again.
It does.
Okay.
Okay.
So next, thank you, John. Next we have from Tennessee DOT, Mark Woods. Mark,
Can you hear me okay?
yes, I can.
So, I mean, ours is pretty simple. I mean, Tennessee, we've just had some of those projects like what John described. We had more often than we'd really like, not like hundreds of projects, but we had a handful of projects each year, between 2010 and 2020, or where they were typical mill and inlay projects that had no preliminary testing. They were just resurfacing projects. And when they went under contract, the contractor would begin to mill and find just, sometimes just an inch, sometimes 2 or 3 inches of just stripped material under the prescribed mill depth. And they'd have to stop construction. And then, you can't proceed until you really have a change order in hand. You can't go to work until you really diagnose the problem. The industry really put a lot of pressure on the department to, in their paraphrasing, they just wanted us to core everything before sending them. So, well, we deliver like 230 resurfacing projects a year. It's like, and you can cut, you guys know, you can cut 1 or 2 cores and you're not going to find it. If the stripping's out there, you may miss it, and you're not going to cut a core every 10 feet or even every 500 feet on 200 some odd projects. We got an on-call, so we procured an on-call contract for GPR, FWD, and coring. And, that was really kind of at the center of it. We were hoping that maybe we could have a third-party firm help us start testing some of these. A lot of it, when it started coming to market, we awarded contracts to 2 vendors and put them to work. And we handpicked some projects just based on distress and all that, and did GPR and coring and FWD to do an AASHTO 93 back calculation just to make sure we're basically doing payment designs on research and jobs. And in the middle of it, we kind of hoped that if there was some stripping or some damage identified, that we could get that through that data. And our first delivery a couple of years back, everything went pretty well. But in one of our first deliveries from each of the 2 vendors, we would have full GPR data and coring and FWD, and then in the core report, 2 or 3 of the cores would just be completely disintegrated in the middle, and it wouldn't be addressed anywhere else in the GPR or the recommendations. So we had individual meetings with each of the two vendors, asking them, say, hey, look, what we want is to be able to identify the limits of these strip locations, like your core showed stripped. And both vendors independently said, that's just not something that we can do. They kind of brought us up to what John and MnDOT has already presented, which is these guys know their GPR stuff. They just said what we were asking for was not something they were going to be able to do at this time. It just, the state of practice needed to move along. And then just by chance, I actually was talking to John of Missouri on the phone about something unrelated, and was complaining about my problem. And he mentioned this pooled fund and said, you may want to think about contributing to this study. So I presented to the TDOT research committee and said, we need some money. And they very quickly said that was fine. And that's kind of the entire Tennessee story.
Okay, let me take a quick look here. Any chat questions? Just another comment about the PDH credits certificate survey link is there. Nothing else, Mark. So thank you. So next up from Texas DOT is Ruben Carrasco. Ruben, are you on the line here now?
Yes, sir. Good morning, everybody. So I don't have any slides. Just wanted to just give a just current status in the practice here in Texas. As Mark mentioned, a lot of our projects that are being rehabilitated are missing upfront testing. Right, that's when we found out later with early failures that hey, we missed something. Right. And although moisture damage or stripping issues are not widespread in Texas, it is still present in our network. We usually see this issue in older pavements that have been heavily rehabilitated over time with several layers of asphalt, that being seal coats or hot mix. But even in older pavements, stripping is usually we observe in localized areas. It's not, we don't see the issue being on consistently in the entire older sections. It is most common in gravel mixes, but we also have seen stripping in limestone. We have that's the majority of our aggregate in Texas. One of the common scenarios where we see stripping is on old concrete pavements that have been overlaid with hot mix. And even though we have contracts with consultants that can collect GPR with us for us, and also ISCs with some universities like A&M. It is still kind of a very limited knowledge on how to analyze these data. Right, we have GPR antennas, air launch, and ground couple. We feel comfortable with the data analysis and the results, but we still need to conduct coring to confirm anomalies such as stripping. We started utilizing a 3D antenna. We are evaluating it. But however, the main issue with this 3D GPR is the size of the data files that are generated. It's not easy to store the data or transfer it. So, like I said, this is still under evaluation. We are very interested in this, the results of this pool fund study. We're looking at specifically, what kind of time savings we can obtain from these recommendations, and also the level of confidence to identify stripping. But the as I mentioned, one of the concerns is the volume of the data and how to manage it. That is our main concern there. So that's what I have for Texas.
Okay, thank you, Ruben. No more.
Steve, can I comment?
Yes, is this Eob?
Yes, yeah.
Go ahead.
Thank you, Ruben, for touching on those. I just want to add, we are very confident that the stripping and moisture-related damage is like the low-hanging fruit of this PULFA study. As a group, we will learn a lot of this technology that are even sometimes not related necessarily to stripping. Some of them you touch the data storage. We have some data storage thinking that we've done. We will, as a group, we will love to work with others. What is the best way, and also we work with the vendor. But thank you for joining. Also because this will give us another. As I said before, our stripping mechanism is mostly related to the cold cycles, freeze thaw cycles. In your case, you have different type of stripping, so that will be also help us to see different type of mechanism. But at the end, through this process, we will not only, we will try to have something for stripping, but we will also learn a lot about the tools and share them among us. So I just want to echo on that.
For sure. Thank you.
Yeah, thanks, Eob. Just, one other comment about making sure that the practicing engineers and folks know that this pooled fund even exists is one of the main reasons for this peer exchange today, and to make sure we get the word out about what's the anticipated outcomes of it, and how other state DOTs are looking to utilize the findings and research that'll come out of it. Okay, moving on to Illinois DOT, we have John Sanger, and I believe I have John's presentation up. Can you see it, John?
Yes, I can. Thank you,
Okay,
Steve.
go ahead.
Okay, so Illinois just recently had a project on one of its secondary interstates, Interstate 270, around the north side of the East St. Louis area, headed towards the St. Louis airport and things like that. This project was originally a jointed pavement that was overlaid several decades ago. Over time, it's built up multiple layers of overlays, and we essentially put on a ultra thin bonded wearing course to really kind of try and preserve the latest rehab treatment. In doing so, we basically accelerated some stripping that was already starting to occur down in the lower lips. So as you can see in this slide, we've started to see some severe rutting and then some what appears to look like alligator cracking, but it's not really any necessarily some fatigue cracking. Next slide, please, Steve. And those quickly progress to these pothole-like distresses that we're really going pretty deep in order to get to some of those weaker layers. Next slide, Steve. Again, just another shot of some of the rutting that's present on this section of roadway. And then, as you can see, we're starting to get some actual shoving going on because of the instability or the lack of stability in the lower lifts. Next slide, please. We actually started getting some bubbling or some blisters going on below the ultra thin bonded, and the district went out to actually drill some holes in the surface in order to try and relieve some of that pressure from the trapped moisture. Next slide, please. As you can see here, it's starting to actually push the pavement markings off to the side because we're getting so much pavement deformation occurring in that wheel path and in the subsequent area next to it. Next slide, please. Just another shot from a different angle. Next slide, please. This is a close-up of one of the early signs that this is starting to happen. It almost looks like there's remaining salt scaling left, or if anybody's got pavements that are subject to decracking, it kind of looks like that. Start of a bird bath with the vines coming through, but that was not the case. Next slide, please. So this is one of the big problem areas that ended up showing up. As you can see, that's a pretty extensive patch that needed to be placed by operations. Next slide, please. And that is what came out of the patch when I went to repair it and actually do a full depth repair down to the concrete. The operations yard so that they could take that HMA at the bottom lifts and mold it like Play-Doh. So next slide, please. So we ended up going through and doing basically a bunch of coring over this 10-mile section. As you can see, we've got kind of outlined in different colors the various overlays and things like that that have happened over the years. And then you can see the unconditioned tensile strengths that were recorded based on the layers. As you can see in some of the sections and or in some of the mileposts, as soon as you get beyond the wearing course, it got pretty bad. Next slide, please. And then this is the conditioned. We had some sections that just didn't even record any results whatsoever. So we had a pretty big problem on our hands, and we think we've addressed some of the problems so far. My fear is that there's still more out there that's underlying that could come up and bite us. We just don't have the time or the resources to do as much coring as we really need to in order to determine the full extent of the problem. So that's our hope, is to be able to create a more intelligent way to conduct coring and to conduct pavement investigations for our state, especially since we've got some aggregates that are really prone to stripping.
Jan, were the tensile strengths conducted on the extracted cores or laboratory fabrication?
Yes, the tensile strength, or the testing was done on the extracted cores from those locations.
Oh, okay.
And we tested all the concrete, and the concrete had PS compressive strengths of 6,000 and greater. I mean, there were some that were reaching 8,000, 9,000 PSI. So
wow,
the concrete was in good condition.
Do you think this road would be a candidate for the study? Do you think we can include this, or will be already repaired by then, by next year?
Well, we're trying to just hold it together while we can. The intent is to widen a majority of the roadway in, I think 5 years is what they're telling us. But assuming that, the budget holds the way it is, and we know that never happens with state DOT. So I think this would be an excellent candidate, and it should still be there by the time we're ready to do some testing.
Great, thank you.
Yep, thank you.
John, this is Xuntao Dai from Minnesota. During the construction, did you check the density? Did you get the density?
Of the ultra-thin bonded wearing course?
Yeah.
We did not check the density on the ultra-thin bonded just because it's on the existing pavement section.
Yeah.
No, we have not done that.
Okay. Thank you.
Yep.
I think Ashley is trying to be admitted. She's waiting to be admitted to the room. I don't know if she was able to.
What's the last name?
Ashley Bass, I think, is showing up again. Maybe she's already in. Are you in, Ashley?
Yes, thanks. I was having some connection issues.
Okay.
All right. Well, thank you, John. Next up from Mississippi DOT, we have Griffin Sullivan. Griffin?
Hey, good morning, everybody.
Morning.
In Mississippi, we have some unique material challenges. Most of our mixes are majority crushed gravel aggregates. So we already have some materials that are susceptible to stripping. Back when we started doing super pave, we made some mixture adjustments to address some of those material issues with stripping, and it's worked really well. But we still do occasionally have some issues with stripping, primarily in some of our older pavements, the bottom lift of asphalt and sometimes intermediate lifts experience a bit of stripping. And, you know, from Mississippi's perspective, we're just trying to add another tool to the toolbox. You know, oftentimes when we're working up a job, we're doing our traditional coring, occasionally running FWD, but we end up missing some things. So that's kind of what piqued our interest in this pool fund study is getting another tool in the toolbox. You know, we want to do right by all of these projects that we're working on, make sure we're doing the right rehab treatment. So really, that's our perspective right there. I don't know if I have anything unique to add that hadn't already been said by another DOT. I wish I had some cool pictures. I should have looked some up before this, but that's all I got, Steve.
Okay, well, Griffin, I'm definitely hearing a common theme here on a couple of different themes, actually, but the not knowing and not being able to know in advance the construction projects is really important, and hopefully we can advance that kind of information to the future here through this pool fund. Okay, thank you, Griffin. Next up is Georgia DOT, and we have Ian Reich from Georgia. Ian?
Hello, can you hear me?
Yes.
All right. Good afternoon, everyone. My name is Ian Risch. I'm the state pavement engineer at Georgia DOT. A couple years ago, we got an ultimatum that we needed to do coring and pavement evaluations for all our interstate maintenance projects after a couple of really big change orders on construction. We had some material from the 70s and 80s called B-Mod asphalt, which was pre-lime, anti-strip, and also lowered AC content due to the oil crisis of the 70s. So we do have some bad material buried in our pavements, and we try and make sure we catch it with coring whenever we can. But now that I've got some new contracts, which include 3D GPR and TSD data collection, we're going to add that to our repertoire. We also do something different than everybody else. We do Hamburg wheel tracker testing on our retrieved cores on our pavement evaluations. So I'm looking to expand correlation of data with Hamburg in addition to other forms of non-destructive and other destructive testing in order to identify where strip material is and hopefully delineate it better so that we don't just have to take a wash on the whole project if that's not necessary. And so I'm just hoping to get our research unit to approve us to participate, and then I'll be starting a bunch of work on projects with coring and TSD and everything else this spring.
Hey, thank you, Ian. Just check the. Nope, no more. Okay, so the next person on the agenda was from Kansas DOT, and that is Rick Miller, but Rick has jury duty today. So he alerted me of that as a possibility when we first set this up, and he wasn't sure, but late last night or early this morning, I can't remember which, he sent me a notice saying he's definitely on jury duty. So we do have a, he recorded a presentation that we can play.
If you can hear sound, we can't.
Can you hear it now?
There's a setting you have to change to share sound from your computer, and I haven't done that before.
Okay. Let me.
It's a team setting.
Yeah. Hmm. All right, well, while I'm trying to figure that out, I'll do that over lunch since that's our next thing on the agenda here. So why don't we all take a quick lunch break and come back at 25 minutes, 1:25, and I'll hopefully have this figured out by then. So I don't want to waste your time.
Thank you, Steve.
Settings. Option.
Hey, Steve. Brian, I just sent you a text with some directions on supposedly how to get your audio sharing.
A text.
Yep.
Okay.
Yes, sir.
All right.
Sorry, not an email.
It's in the chat.
Oh, yeah, Ian put it in the chat as well. So.
Okay. Share. Oh, there. Is that it? That little button. Brian, you still on the line here?
Yes, I am, Steve.
Okay, let me try this again. Just if it, we'll just start it, and if it works, then just let me know.
Okay.
Nope, not that one.
Sorry, I'm helping to run a webinar for FHWA. We're about to go to lunch, so we're just testing something out real quick that wasn't working.
Is that coming through?
I'm not getting anything, Steve.
Yeah, we were able to hear.
Was that you, Di? Try it again. Brian, were you able to hear anything? Brian?
I didn't hear anything, Steve.
I clicked on that button. I don't know what else to do.
Brian, are you seeing the slides displayed? I'm not.
Oh, crap. There we go. Let's try this one more time. Did it come through now?
I'm not seeing anything, Steve.
I'll try this noise suppression. Turn that off.
It's like the slideshow's not playing.
Did you see the slides at all?
No.
No slides.
I see it now.
Yeah.
Did that work?
Yes.
Oh, excellent. Okay.
No, Steve, now it's not showing. You're actually showing the team screen itself. Can we go back to the slide? Is that what you're trying to do?
The presentation?
Yeah.
Okay.
That's what we are trying to do, right?
This is it. Yeah.
Yeah.
You can hear it, Sajith?
Oh, is there an audio with the presentation? Is that what you're saying?
Yes.
Yeah, I've not been able to hear it, Steve. Sorry, I had a phone call come in.
I haven't heard any narrative, Steve.
No, no. Sorry.
So did anybody hear that?
No.
I did not.
Oh.
No.
So is there benefit just going through the slides and reading off of them, Steve? I don't know. I haven't looked at them. Obviously, it won't be the same, but
Yeah. It might be better just to include it when we
Yeah.
send a link to everybody, because then they'll be able to individually hear it.
That would be fine.
Oh, that's too bad. Hmm. Okay, well, I'm going to stop recording for 15 minutes here so that we don't have huge files.
Hey,
Anyone?
Steve.
Yes.
While you're at it, can you download the participants if you haven't done that yet? I can't do it from my end.
Let's see here. Yep, there we go.
Thank you.
Yeah, thanks for reminding me, Jeff. Okay, I'll see you guys in about 10 to 15 minutes.
Okay.